Hey guys, tonight we're going to discuss how to do a transparent multisig in Zcash land. And this is separate from Frost, which involves shielded transactions and has other features that are not going to be discussed today. But this is a more traditional Bitcoin style multisig in the event that you wanted to use it with transparent addresses and Zcash. So the general overview is going to be we need public keys, which you can gather either using an Ian Coleman or you can use zcashd, create some transparent addresses, perhaps through a UA, and you can use the transparent receiver. And what we actually need is to extract the public key, and there is an option in zcashd to do this. And we can get to that using the get pub keys script that I will include in this demo. So moving forward, we get our needed public keys. We're going to actually need, so assuming we want to create a 2 out of 3 multisig, in this demo I will need 6 public keys, 2 for each participant. So let's say there's 3 people and we want to, because the idea here is we're going to create one T3 address for the main account, and then we're going to need to create another T3 address for the change. Because as it happens, when you send using these raw transactions in zcashd, if you don't include a change address, if there's any change, it would go straight to the miners. Big oof. So be careful there. I just want to point that out. And okay, so another thing to keep in mind is when you create your multisig, the order of the pub key matters. So pay attention to this. And so after we create the T3, or we'll fund it, I'll just send some funds through Y Wallet or Zashi, or your wallet of choice. And then the next step is to create a transaction. Now before we do that, we need to talk about signing the transaction. And the reason that's important is because you need to use private keys to do so. So in this example, I will simulate having only one private key, because in the real world you're going to send out 3 people could be living in 3 different locations, and we all agree that we want to send a transaction, but we all have to sign it. So the creator of the transaction will sign it with their private key, and then they will create a raw transaction hex that is output, and that's what you will send to the other folks that will sign the transaction. And so they can use their private keys. So that's kind of generally what's going to happen here. So in the sign multisig transaction script, there is some variables for private keys, PK1, PK2, PK3. So you can add just the single PK1 if that's all you have. And like in this demo, I could theoretically, since I'm creating these addresses manually, I could sign them all at the same time to save time, but that's not realistic for most use cases. So I'm going to simulate doing it the long way. So with that out of the way, once the transaction that is created is signed by all needed parties, you just need to broadcast it using zcashd, and I just did a quick wrapper script for that. Send multi-signed transaction, and that'll send it to the mempool where it'll get mined and the transaction will be complete. So let's go back up top, and the first step here is I am going to use Ian Coleman's BIP39 this guy here, this mnemonic code converter, as it'll save a whole bunch of time. We'll just go here and here. put this to Zcash. Oops, there it is. So generate, so each seed phrase generates a laundry list of T addresses, public keys, and private keys. So since in our demo I'm looking for 6 public keys, I'm going to do this 3 separate times. I will save this information in the bottom of this. Here we go. So there's one person, and we'll do another person. Generate. Okay. And I'm choosing the index 0, 1, and 2, but it doesn't matter. This is just for demo purposes here, so that we have both the public keys and the private keys associated with them, because that's essentially what is needed to complete this task. So now that we have our 6 public keys, it is now an exercise of running our create multisig bash script here. So the syntax, create multisig, and it wants 3 public keys. So let's go ahead and copy and paste here. I'm going to do these in order because the order does matter. 1, 2. Actually, you know what? I'm going to do one more person here. Let's do it like this. So we have 3 people. Copy. There we go. 1, 2, 3. 3 people. So I can clear this out. I'm going to start over. So I will do, for the first transaction, I will do the index 0 of each person. So that will be this one, and this one. So copy. Copy. And copy. And what is output is the T3 multisig address and what is called a redeem script, which is what each person who creates a transaction will need to complete this process. So now that we have the first address, let's create a change address. So I will do a separate set of public keys for that one. We'll do index 1 of each of the 3 people. And again, in real life, you would have to communicate amongst the group of folks doing this the public keys, because obviously me having access to all these private keys is not realistic. But in this case, this is how it's going to be demoed. Paste. All right, notice how we have a new T3 address and a separate redeem script. So next up, I am going to actually create the transaction. And we do that, or actually, excuse me, first we need to fund the address. So let me display our first T address here. And I will fund this and I will be right back. Alright guys, I am back and we had sent funds using Zcash into the new T3, and let's just verify that real quick. We'll plug in the address there. We got the amounts, one transaction, and to get the transaction ID, which we'll need, I'll have that right there. So, to create a multi-sig transaction, a few things we're going to need. The transaction ID, which I have here, which is just the transaction ID of the you sending funds into the address. The vout index, which is the index of the output. So I actually have a TX detail script which will help us. It just uses get raw transaction. It's kind of a wrapper. So the way it works is you get TX details, plug in your ID, and we're going to want the vout value for the index. So let's go ahead and pipe this. Or excuse me, that is the amount. To get the index, it will be here. So we just change the end of this string to get what we're looking for. And then lastly, we're going to need the script pub key. And you can also get this information on a block explorer, but since I'm running my own node, I can just do it locally. So we have transaction ID, yep. The vout index, got it. Script pub key, yes. The redeem script is actually what was sent out to us when we first created our multisig. So that is this guy here. And the old amount is the amount that we sent in. So that will be here. And then now we need a new T address, which I will get, and the amount. We'll just choose an amount for the demo. And then lastly, we need to input our change address. In this case, it's going to be this guy here, because we're going to want a new multisig for the change so that everyone can still control the funds. Okay, so alright, so I have a new T address. You can just create a new account on YWallet, for example, to generate this quickly. So we'll use this in our building of the transaction, and we are ready to go. So let's go ahead and create this. So the syntax is going to be create multisig tx .sh. Now we need the transaction ID. Copy, paste. Next we need the vout index, which is in this case 0. Next we need the script pub key, which is this guy here. Next we need the redeem script from our original multisig T3. Copy, paste. Now we need the old amount, which in this case is 0.015. And now we need the new T address. Plug that in. And now we got to choose the amount to send. I will send 0.01, just to keep this simple. And then lastly, we need the new, or the change address. So I'm going to use this second multisig that we created in the first step. Copy, paste. Okay, now before I submit this, I want to do a quick look at the sign script, because remember in the beginning I said we got to adjust the private keys that I'm going to use. So in this, you can uncomment the ones you want to use. This guy will use all 3 keys at once. This one will use 2 keys at once. But I'm going to simulate a single key. So these ones won't apply, so I need to update my private key to the ones that I used in the demo. So it's going to be this guy here. We'll just do a quick swap. Save it. And now we're ready to submit this transaction, or to create the transaction. So you hit enter. It gives you a quick transaction plan. So we have our old amount, the amount we're going to send, and then the change. Do we want to proceed? Yes. Raw transaction created. So notice this long hex string that's created. That is the initial raw transaction that this script outputs, and it asks you if you want to sign it. And the script that we just adjusted the private key for, it's going to use that key to sign. So in the case where you have all 3 private keys, if you hit yes, the complete transaction will be ready to send. But in this case, I'm only using 1 key, and this is what's going to happen. Result, false, more signatures needed, and it gives us an updated raw transaction hex that we need to send to the other parties to sign. Because if you remember, the initial setup here is a 2 out of 3, so we need at least 1 more signature, otherwise this transaction will not send properly. So to do so, we're going to sign multisig transaction, and the inputs are very similar: the transaction ID, the vout index, script pub key, the redeem script, and the old amount, the new T address, the amount, and oh no, hang on, that's the wrong one. Pardon me, guys. Sorry about that. It's this one here. So the updated raw transaction, the index, the vout, the pub key, and the redeem script, and then the initial value, which in this case is 0.15. So let's go ahead and give it what it wants. So we're going to need this guy here. Copy. And then the transaction ID, which we have here. The index, 0. Script pub key we have as well. The redeem script, which I have here. Copy. Paste. And the last thing we need is the initial value, which in this case is 0.015. Now before I submit this, remember we need to update that extra key. So I'm going to take away this key for now, and I will do the second private key here, which in a real world example I would know, and the person who you sent this updated hex to would have to know, would have to use their private key locally wherever they're at. So let me go ahead and paste this, save, and now we are ready to sign with the second private key. what happened here. Let's double check. Make sure I didn't mess up. Oh yes, I did the wrong private key. It's this guy here. Because remember, each of the three are for the same person. So let's go back and update this. But it's good this is happening, because you'll see what happens. If you don't have the right private keys, it's not happening. So we'll go ahead and hit up. We're going to do the exact same setup. It's just we updated the script with the new private key, and now it should work. Bam. So complete, true, and we have a hex. This is a raw transaction, a signed raw transaction that can be sent to the Zcash network. So the last step here is to broadcast. So you'll notice I have a live view of the mempool down here. So as I send this, we will see the transaction and verify that it's working properly. So the syntax for this is send multi sign tx, copy, paste, enter, and here's our transaction ID 2197FC05. And let's see if this gets sent properly. There it is. In the mempool. As soon as this gets mined, I will be right back. Alright guys, the transaction was mined. We're on the next block. So now what we can do is head over to our Explorer here, and oh yeah, there it is. Visit Explorer, mainnet. Okay, what do we see? We initially were sent the 0.15, and then we created a transaction that was signed by two separate people. And let's take a look at where this went. Good view transaction. We started at our initial multisig, and we sent it to this address here, the 3YHN. So now we have our 0.01 sent to where we intended to send it, and the change went to the new multisig, the WH6, which if we go up to the top here, that is precisely the second multisig that we created. So now the same folks that signed the initial transaction will need to sign this other. Will need to sign for other transactions that are created from this change multisig address. So there you have it. It's quite involved, and I hope this is proof of why we need Frost. And I hope, because not only does Frost let you use shielded addresses, it also lets you do things like regenerate lost keys and all this other fun stuff. So I hope this was educational, and I'll see you next time.